This is actually a satellite view of the most recent one, the Wilkins ice sheet breaking off. This is a 26-mile long iceberg here. And again, it was balanced with its edge on the continent and its tail in the sea. It fell off, and then that could allow the ice sheet behind it to move by gravity faster. One of the more recent stories, even since the last IPCC report, is that sea level is rising a lot faster. Just 10 years ago, if you were to ask me, I'd say, well, again, satellite data is pretty good on this, and it's rising maybe about an inch a decade, something like that. And so that would be a foot in 100 years or so. But now the rate seems to be roughly double that. And the new estimates, not counting abrupt climate change, but the new estimates just from the ice melting, as I showed you on Greenland, is about 0.6 to 1.8 meters. So roughly 1.5 feet to almost 5 feet higher sea level in just the next 100 years. Oh, I should mention that prior to this time, the sea level rise that had been measured and we were experiencing was virtually entirely due to the thermal expansion of the oceans. I showed you that they're 1 degree Fahrenheit warmer. Water expands as it warms, so it was very consistent and very easily calculated. But now the big change in the equation, the change in the slope of this line, is the melt rate off of especially Antarctica and the continental glaciers melting. So most of the glaciers on the land are melting worldwide, and that's adding to the sea level rise. Again, nobody hardly talks about abrupt climate change, but if that were to happen, there'd be a significant raise in sea level in a rather short period of time, let's say a decade or two, and these are the areas in blue that would be inundated as a result of abrupt change like that. Pretty dire consequences for Florida and Bangladesh and parts of Africa and so forth. Well, that's climate change far. Let's talk about climate change near in Iowa. As Sarah said, there was a recent report. I was a member of that committee, as were all these other folks who are listed on the left lower part of this slide. It was meant to be a Regents committee, and Senator Hogue may be able to inform us better, but I would say the purpose of the report was that there's a lot of skepticism in Des Moines and in the State House about really whether we should do anything. And so the question just was, well, tell us exactly, what are the impacts on Iowa so far from climate change? That was our charge, I would say. And I'll try to show you some of the things that we found out. One of the clearest thing in the record, and now we're talking about a record that only goes back 100 or 140 years. The clearest thing in that record is that in the Midwest, there's been an increase in the intensity of precipitation. That's the absolutely most clear thing, highly statistically significant. The rainfall events have increased compared to 100 years ago. I won't read all the literature on the left-hand side, but we think we understand why. We have an infrared satellite, the AIRS instrument on the NASA satellite, and it shows increasing moisture in the atmosphere, most importantly, very high in the atmosphere, where the most intense storms are spawned. So within the last 50 years or so, certainly within most of our lifetimes, there's been a significant increase in the frequency of the 1% events, the strongest storm events in precipitation. About 31% increase in the Midwest, and I was a part of that. But check out the Northeast, even much more in the Northeast. Remember Rhode Island and Massachusetts last year. Remember Ohio, Illinois, and Indiana right at the current time, and all the storms in Iowa as well. That's the clearest thing in the record. And this is a frequent reminder to me of our building. You may know this actually didn't, the sandbags happened to hold here. This flooded inside out. It came through the steam tunnels and flooded on the other side, but we were not spared. And as you know, it'll be years before University of Iowa can recover from the flood of 2008. There's pretty good evidence in the record, not that winds have increased. Actually, there's some evidence that winds have decreased, which is counter to some speculation and hypothesis, but that the extremes in precipitation and the extremes in temperature have increased. In fact, again, markedly, as temperatures started to go up, I showed you in the last 30 years where we think the effect of greenhouse gases are really kicking in. That's the same period that the extremes have begun to increase. It stands to reason that there's more energy that has to be dissipated in the climate system, and that mostly so far we've only been talking about the averages, the means, but really the climatologists are only mildly interested in that. It's really all about the extremes, what's happening to the variation. And that seems to be increasing both precipitation and temperature. Now, if you ask about the average temperature in Iowa, you may remember from the very first slide on temperature that the Arctic was a lot hotter, but we were sort of kind of average. And indeed, we're kind of like the global average. Our increase in temperature has been, because we're in mid-latitude, our average increase in temperature has been roughly the same as the planet has experienced as a whole, around 1.4, 1.5 degrees Fahrenheit over the past 137 years. This is data from Gene Tackley, the committee member and climatologist from Iowa State University, who really was the only one to examine primary data for the report, and I think we owe him a debt of gratitude. Well, you say, well, it's 1.5 degrees Fahrenheit over 137 years. Well, when exactly does that occur? Mostly in the wintertime and mostly at night throughout the year, especially in the summer, I'll show you. So these are wintertime temperatures in Iowa. They're 3 to 5 degrees Fahrenheit warmer in just the past 30 years. So you may not believe it from the last 3 winters we've had, and I lose a lot of credibility with these tough winters that we've been having. But indeed, the winters are warmer and really significantly warmer and milder. So we're living with climate change already, whether we want to admit it or not.
When they do something like that, are they averaging the high and the low each day and then working with that? Are they doing hourly temperatures or what?
Daily. These are, this is a kriging process that they do on daily temperatures from the meteorology stations.
High and low average for each day.
And then smeared with the kriging. I'll show you some point data in a minute. That's kind of interesting. Again, Gene Tackley worked up the number of frost-free days. Farmers already are responding. When I moved back to Iowa in 1977, the average day of planting was second week in May. May 15th, May 10th to the 15th was the average day of planting. It's about a month earlier now. They're moving it up and continuously moving it up whenever they can get into the fields, because they're worried about the fields being wet also. So clearly we do have a longer growing season now. That's a good thing, right? I think that's a good thing, at least for the purposes of growing certain crops. And yields are up, to be sure. We think yields are up mostly due to the seeds that are being planted in the genetically modified crops that are pervasive in Iowa. They're performing extremely well. But also because we've had an awful lot of moisture, as we've seen. And you can get too much, But in general, it's important to have enough precipitation for the crops to do well. Last year, it's hard to recall already, but it seems like so long ago, but 2010 was actually a really hot year, especially on the eastern coast, as you can see from this. The red dots are all-time high temperatures recorded for the summer, June, July, August in 2010. You can see awful lot of, these are record temperatures in a 125-year record. So that's pretty remarkable. But you'd say, well, gee, Iowa doesn't look too bad last year anyway. We're just looking at a single year now, and climate is all about decade to decade and longer. But our nighttime temperatures is what was peculiar about Iowa and fits the whole climate picture that we're examining tonight. We had a record number of stations in Iowa with record nighttime summer temperatures. So this is consistent with the story that I mentioned earlier of the air satellite and more moisture in the air. Water vapor is a greenhouse gas, as you know, and it helps to trap the energy into the earth so the nights are warmer. And we see clear evidence of this in the record, including last year. Well, you say, well, if global rainfall is increasing, the hydrologic flywheel is spinning faster, right? Yes, it is. So how much is Iowa increased in precipitation? Well, only about 3 inches in 137 years. But you may recall in the intensity of precipitation map, we're kind of on the edge. In general, everything east of us is wetter, warmer, and everything west of us, for the most part, is drier, warmer. So we're kind of on the edge of this pattern. We're being influenced heavily by the Gulf Stream still. And Gene Tackley, our climatologist, warns us that, you know, being kind of on the edge, the patterns could change. But at the moment, we're wetter, warmer. And that's probably what you should prepare for or expect in the future is more wetter, warmer, because the greenhouse gases and the emissions, as I showed you, are increasing so dramatically. So being on the edge of these two patterns, we see a very clear pattern in Iowa from west to east. So even though the average is only 3-inch increase in 137 years, the pattern in the eastern part of the state is much more. I've got these a little bit out of, shoot, what did I do? Yeah, oh, I missed it. Yeah, this is one I wanted. So Cedar Rapids, more in the eastern part of the state, has had about an 8-inch increase, something like this, much more. I grew up in Davenport. I remember as I was growing up, people would say, well, we get 32 inches of rainfall a year in Davenport, right? Wrong. You know, now it's about 38 inches of rainfall a year in Davenport, just in my lifetime. So these changes are rather dramatic from the standpoint of how quickly they've occurred, actually. One of the interesting things in the record is the more moisture in the air, right? That means higher dew points. Farmers know about this too. They've not only changed their planting techniques, but their harvesting techniques, because generally you don't want to harvest while the crop has dew on it. And that means you have to work much harder to find a non-dew period in order to get your crop in. And the dew points have risen just in the last 40 years quite dramatically. The red is in Des Moines. I should remind you that not everything is bad about climate change, and not everything is bad about what we've experienced here. We already mentioned a longer growing season. There's more carbon dioxide in the air. That's particularly good for soybeans as a result of climate change. Doesn't do much for corn, but particularly good for beans. More precipitation, good for yields. Warmer winters. What does warmer winter do? Well, it causes us to have less heating days, less degree days in which we're required to heat our homes in the wintertime. This translates into energy savings. In the engineering parlance, it would be a negative feedback loop because we use less fossil energy because now we're warmer in the winter. We don't have to heat our homes anymore.